Welcome everybody. I hope that you are doing well and good. So today we'll be continuing data representation and computer arithmetic, and we'll be seeing the division of unsigned binary numbers. So the topic for today is, or the number 2 is non-restoring division algorithm. So basically I'll just first show you the flowchart of the algorithm. So we'll start and we'll use three things or four things. A is the accumulator, okay. M is the divisor, Q is the dividend, and Q and N is the number of bits, okay. After that we'll just we'll check the position of or the bit of A. If A is less than 0, that is if A is negative or not. If A is negative, then do the left shift of AQ and perform A equals to A plus M simply, or not. If then do the left shift is mandatory, or do the A equals to A minus M. And after all this step, after both these steps, again we need to check the sign of A, okay. If again A is like less than 0 or negative, set Q0 to 0, or else set Q0 to 1. And after performing all of this, do n equals to n minus 1, just reduce the number of bits and do this until n is 0, okay. So there is a looping here, you can see this loop goes there back to the top, and we'll see if n is 0, yes, then again we will check whether A is less than 0 or not, that is A is negative or not. If A is negative, just restore what was original. So go back to the original thing and just restore it. So restore it, okay. And if not, just set Q is your quotient and A is your remainder. And also this step also goes here, okay. So just you can copy it, the flow chart. So, and in a few moments I will be explaining this with the help of an example, so stay tuned for it. So let us see an example. So divide 7 by 3 using non-restoring division algorithm. So first of all, Q is 7, so we need to convert it into binary. So the binary is 111, and our M is 011, that is 3, okay. So now initially we need to set A equals to, and N we know already it is 3, okay. So Q we are seeing that it is 111 and N is 3. So first we'll see the sign of A. So I'm writing here step 1, sign of A equals to positive. See, A is positive, okay, A is positive. So we need to perform the left shift. So we are performing left shift of AQ, okay. So we are just I'm writing the step right here. So 0 0 1, this one comes here, 1 1, and there will be a vacant dash, and this should be 3. And we'll also perform A equals to A minus M, okay. So because A was positive, so A equals to A minus M. So 0 0 1 A and M is 0 1 1, and on subtraction it performs 1 0 0, okay. We'll write the M here, so just update it, no need to change anything on the Q, or we can just simply change the Q also. So we'll just see the sign of A again. So now A is negative, okay. So now set the Q0 to 0, so we are not wasting much more steps. Set the Q0 to 0, okay, and N will remain same, and finally we'll just reduce N equals to N minus 1. So we're just finally writing this. So we have done the first step, okay. So now let us do the second step. So step number 2. Now see the sign of A. So the sign of A is negative, okay. So since A is negative, we need to perform the left shift, okay, and we need to also perform A equals to A plus M. So I'm doing both of the steps. So first we are doing the left shift, okay. This will be 1 0 dash, and this will be 2, and A equals to A plus M. So we are doing it, I'm just writing it directly. So it will be 0 0 0, and Now we have to check sign of A again. So A here is now positive. So we need to perform Q0 equals to 1. So will place here 1, 1, 0, 1. It will be 2. Now finally n equals to n minus 1. So 0, 0, 0, 1, 0, 1, and it will be n. Okay. So I'm just showing you what happened. So 1, 0, 1 plus 0, 1, 1. So carry, and this was the sum of it. Okay. Now finally we'll be doing the step 3. So the step 3 is sign of A. Again we have to check A equals to positive. See, A is positive. So do the left shift of AQ. Okay. So left shift of AQ 0, 0, 1. This will be 0, 1 dash. And we need to perform A equals to A minus n. I'm just performing it. 0, 0, 1 minus 0, 1, 1. 0, this will be 1, 1. Okay. So it will be 1, 1, 0. And we need to check the sign of A again. So A here is negative. See, A here is negative. So we need to set Q0 equals to 0. So 0, 1, 0. This will be 1. Now we need to reduce the number of bits. So n is now 0. So finally, this is an important step. Just pay close attention to this. Now we have to, since n is 0, now again we have to check the sign of A. So sign of A is negative. So you can see the flowchart. You just need to restore it. Okay. So restoring, we have to restore this value. Okay. So 0, 0, 1, and this will be 0, 1, 0, and this n will be 0. This is our A, this is our Q. So our quotient is 0, 1, 0, that is 2, and our remainder, or we are writing as A, is 0, 0, 1, that is 1. This was the decimal answer. So you can, on checking, see that if you divide 7 by 3, it will give quotient as 2 and remainder as 1. So we verified the result also. So this is how you perform division by non-restoring division algorithm. So if you had any problem, just comment below, and if you like the video, hit the thumbs up button and subscribe to my channel for more videos. So thanks for watching it.